Hello, gentlemen. Okay, just check a couple of things. Can you hear me? If you can hear me, can you please say yes, 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 or thumbs up on the live chat? Also, if I stand here, can you hear me on the side of the whiteboard? Can you hear me? Can you hear me? Can you hear me? Can you hear me on this side as well? La 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 la. Okay, the second question, can you guys read the board clearly? Can you actually read all the writings on the board? Good. Okay, that's good. Okay, so this is my third live lesson now. My voice is a little bit dry, but anyway, so let's start. So today, what we're going to talk about is the trigonometry identities, and sometimes this is something that we haven't really done in the past, so you're not really used to it. But before that, we're going to just cover some foundations, and I did cover this just briefly in the class, but I'm going to talk more. So in the past, we learned about algebraic expressions, and what it looks like is just algebraic terms. You can put them together, and it's still an expression without any equal sign. And that's the case. If that's the case, we can't really talk about whether this is true or false. We can't say it's true or false. But if we have the equations, then it's going to be different. Equations, this is a common equation that we can see nowadays, and we can actually solve for x, solve for x. However, we cannot say for every single value of x, this will be true. So we say that it's only true for some x values. Not always, only sometimes true. Okay, this is a key. For the equations, we only say that equations are only sometimes true. But what about identities? Identities is something that we never actually learned before. So I have written one example here. On the left-hand side, you have x plus 2, the whole thing squared. Now, what we learned is in the past, I can expand it. If I expand it, what I will get is x squared plus 4x plus 4. So I can chuck any value of x into here. And if I substitute that same value on the right-hand side, I always get the same values on both sides. And in fact, if you try to solve this one, this is not solvable. This is the key thing about the identities. You try to solve it, but you can't solve it. You always ended up going back to the starting point of the circle. Okay, so now, what does it mean? This is sometimes true. This is always true. Doesn't matter what x value is. Now, another thing is in identity, we love to use triple line here. That triple line, the meaning is identical to. Okay? Now, so this is just a brief introduction about the difference between expression, equations, and identities. And today we're actually going to have a look at some trig identities and how we're going to use those identities to actually prove some questions. So now I'm going to erase this. You can this video will be automatic save, so you can always come back and pause the video and take notes. And if you are a fast note taker, please feel free to take notes as I'm talking about these questions here. All right, so let's start with actual identities that we can actually use. Now, the first one is probably during the lesson time, I did ask my students, what is the meaning of cosine? Now, this co is a prefix, and what that means is actually complementary. Okay, I'm not sure whether you actually remember the complementary angle that you learned when you're in year 9. Complementary angles means those two angles add up to 90 degrees. So the cosine of an angle is actually equivalent to the sine of its complementary angle. What that means is, if I have cosine, let's say 20 degrees, that means this is equivalent to sine 90 take away 20 degrees. So there'll be sine 70 degrees. Okay? So if I say I have cosine 30 degrees, that'll be same as sine 60 degrees. Because 60 and 30 will make 90 degrees. So that actually fulfills the meaning of the complementary here. Okay? So here, based on the meaning of the cosine, you can actually come up with one identity here. So this is going to be the first identity I'm going to write on the right side. We can say that cosine theta is equal to sine 90 degree take away theta. So that is the first identity. All right, now let's have a look at the second one. I'm not sure that if you're not from my class, I'm not sure how many of you went through something called unit circle. Okay, unit circle, just according to the word, what that means is the circle with the radius is 1 unit. Okay, so I'm gonna draw a unit circle. And the radius of this is 1. So that means this is 1, 1, negative 1, negative 1. I'm just drawing this one on the x and y axis. All right, can everyone see my handwriting clearly? Okay. Now, let's have a look. Thomas, I think you joined the wrong class. The year 9 one's finished. Okay, so now let's have a look. So I'm going to choose a point. Let's say this is P, and the coordinate of that point is xy. And I'm going to join that one to the origin. So this, from here, I can create a right angle triangle. Okay, and I say this is angle theta. Now, based on the coordinate that I got, this vertical length is y. This horizontal length, which is the red part here, is x. And I know the radius of the circle is 1 because we are using the unit circle. Now, from here, I'm just going to use Pythagoras. Let's use the trig ratio first. So sine theta is equal to, so this is angle theta. Sine theta is opposite over hypotenuse, which is 1. So there will be y over 1, which is same as y. And the cosine theta is adjacent over 1. So x over 1 equal to x. Now let's think about tangent. So tangent theta is equal to opposite, which is y, over adjacent. All right, let's just pause here. Have a look at tangent. Y is equivalent to sine theta. So I substitute this into this. So that will give me sine theta over x is equivalent to cosine theta. So I can write this. Just by doing this, you came out with the second trig identities, which is always true, that tangent theta is always equivalent to sine theta over cosine theta. Okay, so I'm just going to write this one down here on the right-hand side. So this is the second identity that we got out from the right angle triangle here. Excuse me. All right, so now let's go back to the triangle again. Because this is a right angle triangle, so what I can do is I can use Pythagoras. So if I use Pythagoras, I will get x squared plus y squared equal to 1. And from the trig ratio here, I know that x is equal to cosine, so I'm going to substitute into it. So there'll be cosine theta squared, or just let you know, this symbol, cosine squared theta, is actually same meaning as cosine theta whole thing squared. In trig, we put this little power in the middle top. Okay, so come back to this. So I got cosine squared plus y is sine theta. So this will be sine theta squared equals 1. Now, this is the third identity that we actually came out from the unit circle. So I'm going to write this on the right-hand side. So cosine theta squared plus sine theta squared is equal to 1. Okay, gentlemen, now can I erase this part? If I can erase, can you please just say yes in the live chat? Hello, Finn. Okay, gentlemen, can I erase? Okay, I need to see lots of yes so that I can erase this part. Okay, thank you. All right, now we're going to have a look at what is called reciprocal trig ratios. Okay, let's start with the first one, cosecant. This is the reciprocal of sine. Okay, now what that means is short form for cosecant can be CSC, also can be cosec. Okay, so that means cosec of the theta angle is equivalent to 1 over sine theta. Now let's have your second one. You have something called secant, or some people say second or secant. This is a reciprocal of cosine. Okay, so in other way, what I can say is the secant theta is equal to 1 over cosine theta. Now, you probably can think of the next one as cotangent, which is the reciprocal, I think you already guessed what it is, of tangent. Okay, so from here, I can say cotangent, which is short form of the cotangent, cot theta is equal to 1 over tangent theta. So these are the reciprocal trig ratios. The reason I actually chuck this one here is we are going to start to prove some identities. So the first one that I'm going to do is prove tangent 90-degree take with theta is equivalent to cotangent theta. Okay. I want you to actually think about, just think first. I'm not going to straight away write the answer. I want to think, what identities can I use these three or these three to prove this? And when we say we prove, we are not moving things around from left-hand side to right-hand side. We are proving that the left-hand side is going to be equivalent to right-hand side. That's what proof means. So what that means is you're going to change either the left-hand side, you work on it with the trig identities until you get the look that exactly same as the right-hand side. Or you can work the other way around. You can start from the right-hand side and go back to the left-hand side. Okay. All right. So now I'm going to dive into this. I'm going to start from the left-hand side because I know one of the trig identities that I can use, which is tangent theta is equal to sine over cosine. So this is how you write it. You must communicate clearly. You are talking about left-hand side. So I write left-hand side is equal to tangent 90 degrees take away theta. So which is equivalent to sine. This time the angle is not theta. The angle is 90 take away theta divided by cosine 90 degrees take away theta. Okay. Now let's think about another one. Now, right-hand side just has angle theta. It's not 90 take away theta. But let's think about this. Cosine of 90 take away theta is equivalent to what? Think about the meaning of the cosine. So that is a complementary of the sine. So therefore, this is equivalent to sine theta. We can apply the same thing to the top as well. And the top is actually equivalent to cosine theta. Now, if you look at this, tangent is sine over cosine. And here we got cosine over sine. So this is actually the reciprocal of tangent. So what is the reciprocal of tangent? We know that from the previous one, the reciprocal of the tangent is cotangent. So therefore, I can say this is equivalent to cotangent theta. Now I started with left-hand side. I used the cosine meaning and the identities I got to make a conclusion that is a cotangent theta. But please don't stop here. You must make a note at the end, say that it is equivalent to the right-hand side. So therefore, I use 3 dots, like triangle dot. That means therefore, left-hand side is equivalent to, look at that, I use a triple line here because this was the stage I was trying to prove. So therefore, I cannot use triple line. So now I've made a conclusion. So I can use a triple line and say left-hand side is identical to right-hand side. Now, this is our first proof question. So please just have a look at this question again and just ponder upon it. All right, I'm going to write a second question here. So the second question will be, prove cosecant. Okay, this is what we're trying to prove now. So let's have a look at second 90-degree takeaway x. So from the previous slide, I should just erase it. So for the reciprocal, we know that second is the reciprocal of cosine. So I can start with left-hand side. So left-hand side is equal to second of 90 degrees, take away x. So there'll be 1 over cosine of 90 degrees, take away x. Okay, so we use a reciprocal trig ratio here. And we know that cosine of 90 degree take away x is actually same as sine x. Remember, these two angles add up to 90 degrees. So 1 over sine and 1 over sine, which is the reciprocal of the sine, which is the cosecant of x. So this exactly same as the right-hand side of this question. So I can make the conclusion it is equivalent to right-hand side. And therefore, Now I can make the final conclusion. The left-hand side is identical to right-hand side. Okay, gentlemen, can you please just let me know how is it going? Do you guys actually understand these two questions and how we prove it? Just put yes or thumbs up on the live chat. All good, gentlemen? No response? Okay, good. Thank you, gentlemen. All right, so I'm gonna write another question. Sorry that I'm coughing a lot. Okay, now let's have a look at the next question. You're going to prove 1 plus tangent theta squared is equivalent to, is identical to secant theta squared by using one of the identities here. So which is cos. Okay, so now we're trying to, that's a very direct question. It's literally telling you to prove this using this identity. Okay. Okay, good question, Finn. I'm not sure why you are here, but good to have you. Okay, so let's start from writing that identity out. So we have cosine theta squared plus sine theta squared is equal to 1. All right, now this is quite different from the previous question. The previous questions just gave you one identity and asked you to prove it. And therefore, we actually start from either left-hand side or the right-hand side. But this one is different. This one just gave you the direction. They say use this one. You have to use this one to come out with this. So what that means is we can actually work on both sides together and see whether we can actually make the conclusion of this. So if you look at it, the first one is 1, and the second one is tangent. Okay, I know tangent itself is sine divided by cosine. That's the identity that I have here. And if that's the case, that means I need to do divided by cosine to get tangent. So that actually gives me the hint on what to do. So I do on every single term divided by cosine squared. Because I want to get 1. So cosine squared divided cosine squared. And I also divided by cosine squared here. And I also divided by cosine squared here. So now let's have a look. This is 1 plus, this is actually same as sine theta over cosine theta, the whole thing squared. And the right-hand side is same as 1 over cosine theta, the whole thing squared. Now, let's keep working on it. So that will be give me 1 plus sine over cosine is tangent, which is the second identity that we have. And then tangent theta squared, which is equal to 1 over cosine theta. The reciprocal of cosine is secant. So that will be secant theta squared. So I put the square here. So now, does it look like the question that's given to us? So now we just prove it. And this is the next identity that we actually use it a lot to prove others. So 1 plus tangent theta squared is equal to secant theta squared. Now I'm going to change this question and I want you to actually try by yourself. I'm going to pause for, I'm going to not talk for maybe 2 minutes or 1 minute. You're going to prove that cotangent theta squared plus 1 is equivalent to cosecant theta squared. Again, you're going to use cosine squared plus sine squared equals 1. We actually call this one Pythagorean identity because it's actually from the right angle triangle using the Pythagoras theorem, right? Okay, now please try by yourself for next, let's say 30 seconds. Okay, I hope that you had an idea what to do here. So it says cotangent theta squared plus 1 is equivalent to cosecant theta squared. What can I do to this so I can make that conclusion? Okay, this is where I can start. I want to have 1 here. So what can I do to get 1? Probably I can divide it by sine theta squared on every single side. On every single term. So that will be sine theta squared divided by sine theta squared. Okay. So now what you got is this is cosine divided by sine, and which is reciprocal of the sine over cosine, reciprocal of the tangent. So that's actually, I'm gonna write everything down. Okay, plus 1 over sine theta. Let's put this way first. So cosine over sine is a reciprocal of the tangent, so which is cotangent theta, the whole thing squared. So I'm gonna put the square here. Plus 1 is equal to 1 over sine is, the reciprocal of the sine is cosecant. So it's cosecant theta squared. I think we just reached the conclusion here. So these two are exactly the same. Okay, so this will give us the next identity, which is cotangent theta squared plus 1 is equal to cosecant theta squared. Okay. Now let's dive into a proper proof question. Now, so far what I have done is I have explored all the different ways that we can use to come up with the current tree identities that you will see on your formula sheets and how we actually got these identities. And now what we're going to do is we're going to use any one of them to actually prove their identities. They'll be written on the board soon. So the question is, you're going to prove cosine x squared, take away sine x squared is equivalent to 2 cosine x squared, take away 1. Now, when you are doing the question, what I want you to do is just observe. Now, remember, you cannot move things around. You can only start from one side, and then you have to come up with the loop that is exactly the same as the other side. Which side that you want to start with is totally up to you. Sometimes you can start from left-hand side, sometimes you can start from right-hand side. Now for this question, I look at it, it has cosine squared, sine squared, nothing else. So that actually gave me the hint that I can actually use this Pythagorean identity for this question here. Now I'm going to start from the left-hand side. So I have left-hand side equal to cosine square x take away sine square x. Now, on the right-hand side doesn't have sine, so that means my job is to change this sign to something else. Now, when we are using the identities, okay, that is given from the formula, that is okay to swap things around. So from this identity, I can make the conclusion that the sine theta squared is equal to 1 take away cosine theta squared. Okay, so now what I'm going to do is I'm going to substitute this into my left-hand side. expression. So there'll be cosine square x take away bracket sine square is equivalent to 1 take away cosine theta square. Okay, so therefore now I can expand the bracket. So there'll be minus 1 minus minus become plus. So there'll be cosine theta square. Now I have two of them, so it is equal to 2 cosine x squared take away 1. Does it look like right hand side? Exactly. So now we reach a conclusion. This is look like right hand side. So therefore, left hand side is identical to the right hand side. Okay. Now we just proved this question. Okay, I think I did enough talking today. And I think that is enough for some of you as well. And I hope that you really understand what we're talking about this lesson. And can you please put your thumbs up if you really understand what we're talking about here? And what I have done is I also uploaded a trig note on the Google Classroom. So you can actually flip the pages around and go to the page that actually start with the trig identities. And today you can pick a couple of questions, maybe 5 or 6, and try to prove it by yourself using the sum of the identities here on the board. Okay, so please give me some comments on how the video went, whether the sound is okay, and whether the video quality is all right. You can read every single writings on the board, and or is there any other things that you think that I need to improve? Because today, literally, I just have a laptop in front of me and a whiteboard behind me. So that's how I did this live streaming, and I hope that it will go well. Okay, thank you, gentlemen. So please make sure that if you think there's some parts that I need to improve, just feel free to send an email to me. And I hope that you enjoy the lesson. I hope that this is helpful. Okay, thank you, gentlemen. Have a lovely day. Bye.